Thank you all for being here. And today, I would like to talk about seagrass in northwest Philippines, the absence of the sea bank in Thalassia hemprichii. And first, I need to talk about two features about Thalassia hemprichii to help you know more about this article. So the first is vegetative reproduction and seed reproduction. And vegetative reproduction means asexual reproduction, and seed reproduction means sexual reproduction. Okay, as you can see these pictures, and you can see the rhizomes. Rhizome mean the underground stump, and the underground stump will grow up the shoot. The shoot mean the plant. Okay, and the other is the sexual reproduction of the tea hemprichii. And first is the seed, and the seedling, and the plant, and the final is the fruit, and it's the life cycle. And the second feature, a widely distributed seagrass species. And in this map you can see, and this seagrass is a very widely distribution in the Indian Ocean and Pacific Ocean. Okay, and now I need to definition of the sea bank. And first, what is the sea bank mean? And the sea bank are growing when the flowering plants deposit seeds in the sediment. It means the survival of the barrier seed will be important factor to form the sea bank. And the sea bank is also a crucial survival mechanism for many plants, because you might face some critical environment like a typhoon or some tsunami. And the last, and it might explain why the tea hemprichii population is stable. Okay, and in this paper we want to know, is there any potential sea bank of the tea hemprichii in the northwest Philippines? And the second question is the buried environment suitable for tea hemprichii to form a resistant seed bank? Okay, and the logic of our method. And first, our first question is any potential seed bank in the northwest Philippines. So to figure out this question, we designed an experiment. And the experiment is the seed bank experiment. And the second question is suitable to form a persistent seed bank. And so we designed the second experiment is seed buried experiment. So we first talk about the seed bank experiment. And what is the seed bank experiment? Seed bank experiment is we choose two sites, land. And we choose two sites from the northwest Philippines. And yes, first we choose two sites, sluckweed and the carrot. And we choose the time. We choose time is 1999, July, and November. And the last is the January. And we have 3 times, and each time we use 36 core. And so in the total, we have the 216 cores. And the second experiment is the sea buried experiment. And the second experiment is the sea buried experiment. So we want to know the seed is buried, well, effect. What is the effect to the seed? So first, we use a PVC tube, and its diameter is 10 centimeters, and its height is 15 centimeters. And 3 buried levels in PVC tube. And we close at once in the end, and the 36 in tube. And finally, relative every second day for 2 weeks. And the result. And the result is there's no any tea hemprichii seeds were found. And the second experiment, we can see the control type. The control type is almost leaf, and the 5 centimeter barrier and 10 centimeter barrier is almost there. And the total leaf length experience. And we can see also after the 10 days later, the total leaf length will be very low. And the conclusion, that the resistant seed bank for tea hemprichii is Bolinos is absent. And the high mortalities of the berry seeds suggest that these seeds are not well suited to form the resistant seed bank. Okay.
7 minutes, 50 seconds. Lina. Ethan. Sherry. Andy. Lina.
You said you had an experience in July, November, and January. This means that you had this experience in summer, fall, and spring, and winter. But why you didn't take spring into account? I mean, why you don't take this experience in spring?
We choose this season is because we choose the fruit period and the flowering period. It's not the season. We choose is the. You can see the life cycle of this seagrass, hemprichii, and we choose the plant period and the fruit period, and finally it's the seed period. The 3 periods. We choose these 3 times. It's not the 4 seasons.
Ethan.
To go back to the first diagram. Why the control type is shifting the diagram, the control type?
Oh.
Results.
Oh. The control type is mean. The control type is I say it's the 3 buried level of the PVC tube, and the 3 level is the 0 centimeters and 5 centimeters and 10 centimeters. And you can see the 0 centimeters is much more good, because if you bury this seagrass, and the seagrass they can have oxygen, so they might die. So the 5 centimeter buried and 10 centimeters buried is not good.
Okay. Sherry.
Explain for detail about your experience. What's the result and fix it?
Oh. The experiment one is we want to know, is there any potential sea bank in the Northwest Philippines? So we did some core, and we choose this site, and we had the 3 times, and each time we did 36 cores. Cores mean like 岩溪。
Okay.
And finally, we experienced the course, and we know the result. And the result is there's no seed in this course.
Andy.
I want to know why you choose these 2 sites.
Oh, because these 2 sites is the northwest of the Philippines, and it's the random site. And these 2 sites also have a very large seagrass dam.
Go on to your question. Andy. Chris. And Adrian. Chris.
So you said that you put the seeds into the PVC tube, right?
Yes.
So what you put to bury it? The normal.
The normal site sediment, and we just bury it and put it back to the normal site.
Hi, I want to ask, did the paper discuss about the main reason that the borrowed seed cannot grow in the sand or under sea? Borrowed seed. I think result.
This one?
Yes, this one.
Yes.
Next one, next page.
Next page.
Oh, sorry, previous page. This one. So did the paper discuss about this result?
Oh.
Is it lack of oxygen or lack of sunlight or what? The main reason?
Oh, the main reason is he needs oxygen. And this type of seagrass is original is floating. He cannot be buried. If he be buried, he cannot have the reproduction. So you can see they are a very wide distribution because they are floating to distribute from typhoon or from other animals.
Thank you.
Okay. So I can see that you have tried to speak very slowly, but still it was short. So, part of the reason might be because of the paper, because the paper itself is extremely short, I think. So you need to think how to fulfill your 10 minutes requirement. And, okay, so the strength of your talk is you have added a lot of images and you use these charts to explain how the experiment was done. So I think in terms of clarity, the talk was very nice. But you have missed some details that you should clarify. For example, at the beginning you explained about asexual and sexual reproduction.
Yes.
And you told us what the definition of both types of reproduction, but you didn't tell us the relative importance of these two types of reproduction. Which one is more important for seagrass, for example?
I think
you don't need to explain now. So that's something you can add to help you fulfill your time requirements. So, so I suggest that next time you talk more about the grass, and you also talk more about the physiology of the grass. For example, you can look for photos of the grass, and also you can look for photos of their seeds. And actually, I have a question. Probably, I don't know if you can answer that. Do you think the seed will sink? Because you said the grass float. Do their seed sink?
yes, their seed can sink, but not for not for long.
Not for long.
Yes.
That means they are mostly floating.
Yeah, but about 1 week to 2 weeks, and they don't have the bounce.
They don't have the buoyancy. Then they sink.
Yes.
So they will float first and then they sink.
Yes, because the main dispersal is their plant and their seed.
Then if they float first before they sink, I mean the seed, then the obvious question is, does it make sense to take course right next to the seagrass? That's my question, probably to the others. Because of the currents, the seeds will probably also blow out when at their floating stage. So if you take course only, I don't know how, you say they take a lot of course, up to 36, that's a lot to me. Where did they take their course? Probably they did not say that. Like at which water depth, how far away from the coast, etc. That might be, I was saying, this kind of results is a little bit like, are you sure this is the right results or something? Like if you think about the physics of the seeds, then you might wonder, did they take the right material? That's something you can think critically. If this results is really like that, or is the experimental design is flawed, 有瑕疵的. Okay, so that's my question. But I'm not sure if you can answer that. But I would say next time for your talk too, you may think you can introduce more about the seeds, like their physics. You know, most organic matter should float on the sea. They do not sink naturally. Most organic matter, like you and I, we don't sink. So how would a seed sink? Probably you can explain that. Okay, and then he talked very slowly, so his talk is really easy to follow, and he has a clear purpose statement, so we know very clearly what he wanted to achieve in this study. And then, following one of the students' question, you should really explain clearly. Oh, not this one. The one where you say it takes a lot of course. This is not the end of material method. You should tell us further. For example, some people are asking what is a core. then the easiest way is to add a photo showing what is a core. Okay, because the word core can mean a lot of things. So you should tell us by showing a photo what is a core. And what did you do with the cores? You do not just take them back to the lab and then that's the end of the story. No. You did furthermore on the cores. That is part of your experimental parts. Then when introducing your, and again, this is your the second type of experiment. And you did not tell us at the end of your maybe you check the seeds from time to time, right? What did you measure, check? You just see, okay, the seeds. How do you know it's live or dead? How do you know a seed is live?
And we dig out and we can see if the dead seed.
Okay, that's something you need to say. At least I don't know if a seed is live or dead when looking at it. You should tell us how to do that. Okay, then this is your result. You have a lot of time, so you should introduce the axis. X-axis, Y-axis, and the symbols. Okay, and if you say the control is at the sediment surface, you just write 0 centimeter next to control. Here you have 5, 10, then you write 0 centimeter. And here you say you check the number of live seed. Then here you say total leaf length. What's that? You did not explain. Okay, so that's something next time you can explain further